Welcome to a new test and teardown video. This time I got a suitcase with a side tester. Nice carry case. All the documentation. The little reference chart and operating instructions and serial cable. So pretty cool. The only thing missing is the power supply charger. So I can't power it up. So we're gonna see if we can fix this. So it's a bird side analyzer. So it is not a full spectrum analyzer or a full network analyzer or anything like that. It is only S11, so it's SVR. So this is antenna analyzing. Only one connector here, and it is a little bit loose, both that way and that way. So that is probably why it was tossed. Serial and parallel interfaces and power. Let's look at the rear side of the analyzer. It says side analyzer model SA-2000, and aren't we lucky? Here it says 9 to 16 volts. Positive is in the center. And that is our test port, of course. So let's try and see if I can find a connector that will fit. So let's try and power this up. I think I found a compatible power connector. It's right there. Okay, let's see if that will stick in. Oi! That's exactly what... It's doing some charging and... Haha! Happy! And this is what we got. 12 volts and half an amp. So I'll just let it be like this for half an hour and then I will see what happens. So before I was blowing up my house, just leaving this one to charge, I had the idea, hey, why not just open the battery lid and have a little inspection on this battery pack. It is a lithium battery pack, 10.8 volts. It is from 99. So 23 years old. And as you can see, it is completely leaked and puked in both sides. So definitely we shouldn't charge on this pack. We should remove it immediately. But there are... What have we got here? The controller board. So we could actually restore this battery. But first we need to know if this unit is working before we invest any more time in this, right? With or without the battery connected, this unit is still using about half an amp in 12 volts. So is that its standby, or is there a charger that is kind of broken inside? That is a little bit weird. I guess this is the power on. And now it goes for 800 milliamps. And it looks like it is a live. Current date. So what do I do here? It's running off mains power. Let me remove that one a little bit. So how do I enter? Oh, buttons are measure match mode. I need to play a little bit before I play super dumb here. Now I've been poking around with this for quite a while, and it is clearly that there's some kind of a problem with this one. The buttons here, they only work when you're like more or less standing on them. You need to press them so hard that you are more or less breaking it to get a reaction, especially in the mode, and this is the one you need the most. This is of course because it's those rubber contacts with electrical coated material. Oh, by the way, that one is probably my phone creating a glitch. And other than that, it is scanning and it is sweeping impedance right now, so that seems to be working. And as far as I can see, this is all it can do, so it's only SVR. It's not a spectrum analyzer or anything like that. It's only SVR. So I really need to open this and see if I can fix the buttons here. See, the buttons here, they actually react. There's a 1/4 of a second delay, and that is of course causing a lot of pain. But other than that, this one works amazingly good. This one doesn't work at all. Calibrate doesn't work. Config, marker. Oh, marker worked. So marker's alright. So now I need to figure out how to open it, and then there's another problem. In power off mode, it uses 6 watts and 10 watts in power on. So there's definitely a problem with the charger circuit. I wanted to try and take the battery pack and then cut the wire here and try and input 10 volts like it says here and see if it's using too much power or something. So that is 10 volts on the battery leads. Let's try and see if it... Yes, it also powers up from the battery, and it uses 7.8 watts, and it seems to be alive from the battery. See, it says low. Okay, so let me give it 10.8. It's still low. So how are we gonna get this? See, the only way, yes, select mode, measure match, and then it goes. But it's still in low. So 10.8 is a little bit on the low. I'll just leave it on 10.8. I think I'll just try and turn it on and off and see if that restores the battery measurement. Maybe it's not measuring the battery voltage too often. See? Now it's full. Haha. So at least it will work from battery, and the charger is probably a defect or something like that. So to open this thing, you need to break away the rubber and access the screws like this. So that will require a lot of restoration. Well, that is just the way it is. As it is right now, it is not working. There is no way you can live with the amount of force you need to push the button, so that sucks. I need to know where... Okay, here we go. So that's fairly easy. That is the most gross and annoying. Of course, this is a double-sided tape something. That's just insanely sticky, and I'm fighting. Oh, man, this is just sticky like you cannot imagine. But anyway, I think we are getting our way. We're getting in here. Let's have a look. We got some cables. We got some... Oh, that is easy. Easy to disconnect here, and then we can dig our way to the switches. And we are in. Of course, this is the backlight for the display, and I just barely touched the wire here. And then the wire fell out of the connector, so that wasn't crimped correctly. As you can see here, it just fell out. So of course we need to restore that. So there's a nice shield made of copper behind the display, but we need to get in here and figure out how to... Oh no, it's those one-time press on thingy. I know those are impossible to release without breaking those plastic things, and that means when you need to assemble this again, then how the heck are you gonna do that? So this is a huge problem. They're definitely not designed for service. Hey man, this is a total showstopper. There's a way to break them, but then you take in a screwdriver like this and then you bend them up like this, and then you can take them up, but then you need to put in a new one. Oh, that super sucks. But here is the unit. This is very much 1998. Look at all those ICs full of memory, DSP. What's memory for all that? Probably, what's that, FPGA and CPU and all sorts of really hefty stuff. But really, for what reason? It's not doing a lot other than that, just sweeping the impedance. I mean, why do you need all those ICs for that? There's also a parallel printer interface for HP printers and a serial port. So that requires another FPGA. And that's the backlight high voltage driver. I think we should be able to look at the other side of that. Yes, maybe I can lift this up. And this is the rear side with all the RF goody stuff in here. And that is the battery connector. So this is how it's supposed to be, and it even says battery plus and minus, and then probably a temperature sensor, which is not in use. And then there's this sticker here in the battery compartment, and that one hides access to this switch. This is your EEPROM, says here, reset switch for EEPROM settings. That is all your calibration data. I am actually a little bit impressed about the build quality. See, the RF unit you can detach from the main board, and it's connected via feed-through capacitors and connectors on the main board. And again, you'll see this is a multi-layer PCB, and down here you see the different groups of grounding and powering and all that kind of stuff, carefully grouped and isolated so it's not causing interference. Stuff like that, huh? Ooh, you see here some grounding, funny stuff. So I'll leave this a little bit, but I think what you came for is to have a look inside this box. I know. I guessed it, didn't I? So while I'm opening this, I look at the two screws for the end connector here, and look at that. Loosey. So that was the initial problem. Those two screws, they need to be super tight. So now we're inside the RF unit. There's actually a few things that is very funny. Look at that track right there. What do you call that track and that track? I mean, is that sloppy joppy or what is that? How the heck do you do PCB layouts like that? I am not impressed about that. This reveals somebody had an idea and it wasn't going that way anyway, and they just forgot to clean up. I mean, a cleanup process is very important for a PCB layout, and this way it looks like somebody used their full brain capacity. And this one does not look nice. So that is of course the oscillator inside this little metal case. We got some really cool tracks here. Look at that. And this is a test point where you access something while you're trimming or programming or something like that. That will be some fancy coupling stuff. In here we got the SVR bridge. Got a mixer right there. Oh, classic mixer, by the way. And then we got that will be an RSSI detector, right? And then some op amps, and then we are out again. So there's not a lot more to it than just a software configurable oscillator. We got some divider parts, PLL kind of stuff, oscillator things. Not a lot there. Better have a look inside the SVR bridge. So inside the RF unit, I've been looking a little bit more. I also took away this aluminium shield around the bridge, and this is of course the oscillator. This is the PLL, and here we go with the output. It goes in two directions with this splitter. It goes through this test point you can access from outside, and then it goes to the first little amplifier, and then there's another splitter and filter, and then it goes again, amplifier here. This output goes, I think, is it this way, to this amplifier, and then it goes to the bridge. This is a normal SVR bridge where you compare the two sides. So this is the port and this is a reference. So the input goes via two resistors to both sides, and as long as those two are identical, there's no output here. So that's super easy. So this is the SVR bridge. The other input here is where it measures the level of the drive signal, but it's also used as the signal to fault. So you need to measure the reflected pulse, and this way you can calculate the delay or the time to a fault, and this is also a feature this unit got. So it's also a mixer, down converter, and then the signal level detector. So I think this is exactly what there is to say about the RF unit. It's a really, really beautiful design. It's a 4-layer PCB. This is the back side of the display. I managed to get this PCB out. This is the back side of all the switches. The problem here is this is not meant for service at all. So that means if this is not working, you're just supposed to throw this out, right? But the more you push this kind of plastic, rubber, carbon impregnated kind of plastic, so this is conductive, so it's between 200 and 400 ohms if you measure this a few millimeters apart. And the more you push this, the more it stops being conductive. So then you push even more to get it to give you a contact, and then it just gets worse and worse and worse. And what I'm saying is this is not supposed to be serviced. See, those are like one-time click on. They go through the PCB and they hold down the PCB like that, right? And when you take these out, the idea is you take two screwdrivers and then you gently bend this little springy part up so you can release this from the plastic. But if you push just a tiny little bit on this plastic, it's gonna break. I was super careful about this, but I broke one of them, and that will be the switches where I need to where I know they are not working. So it is in this area And you see, they're also treated with some carbon to give you a good contact. And I don't really see a reason why switch 7 is not working. It's probably, maybe this piece of plastic was already broken, and when I push here, it just bent the PCB up, and this way there is not this kind of pressure that I need to get a function right. But that is definitely the problem, and this is really, really difficult to fix. So I tried to clean all the contacts. At least I think this is more or less all I can do. I was hoping to get a little bit of the contact back on the PCB as well. And then here is the shield, a thin sheet of copper, and it's coated with some plastic, so it should be able to go here. It's on this side, it looks like it's directly copper, huh? So it goes here, and then I will try to assemble it again and see if it's any better. Here is the battery. I took it out of the plastic and it's completely corroded, and there is an intense smell of lithium, so it's completely leaked. And maybe some of the acid fumes from this battery probably escaped into this unit and poisoned some of the contacts and stuff like that. Maybe that is also what happened, but it's also just wear and just old age that caused the switches not to work. But all this lithium fumes and what kind of not nasty stuff there's here, this is probably not good for electronics, and this is maybe because this is shorted, maybe this is why the charger is not working anymore. I believe the charger is in this area up here, because that will be the contact for the battery, like that. And then down here is the input, and somehow this goes all the way to this charger area here, and that is just using a lot of power, even if the power is the battery is not connected and the unit is not turned on. So maybe I can use the thermal camera to see what is getting warm here. This is the shielding before the aluminium plate is mounted. So this is to create a good contact all the way around. But there's one thing that I noted, and if you look at the marks, the different screws left, look at that one, there's hardly any mark. This one is more or less normal, but here there's no mark. And what I also realized is that quite a lot of them, there aren't a lot of marks. And here as well. And all of them, they were very, very loose. Super easy to take out. Oh, and here's another one. Didn't need nearly not a mark. So why don't we see a strong mark around all of them? That is not so good. So this is the moment of truth. I did my very best to reassemble it. And of course it powers up. But what I really want to know is if those switches are any better. So it's actually starting up in measure mode where I left it, so that is pretty cool. It kind of remembers the last measure mode, but listen. Can you hear? Okay, I mean, it actually responds to the button, and I'm not up and standing on them like last time. So I have definitely fixed the problem. What I did is I used a little cotton bud and a tiny little bit of alcohol, and then very gentle, tiny little brush on the backside of the rubber contact and also on the PCB, but just a tiny little brush, because I'm so afraid of rubbing away this carbon coating. So it's just a tiny little top layer rip up, but it's definitely responding to all the switches again. So yeah, it is back to life again. How cool is that? And I was even able to put on the rubber edge thingy here again, and there's still this sticky tape kind of made it go all right. So it's still looking all right. Still, the user interface and the way you set up the frequencies and all that kind of stuff is still a little bit dodgy. I mean, this is just how it was, not super intuitive or anything. It's not super cool or anything, but of course you can still use it.